Hello, I'm Neeraj. Today I will try to explain the concept of RAG, that is Retrieval Augmented Generation technique that is highly used these days with large language models. Actually, the issues are it is very tough to train the large language models from scratch in a small setup or even in a medium sized setup because it requires a huge amount of resources, computational resources, and it contains a billions of parameters. But we can use the trained large language models in a small laptop also. Now the problem with directly using large language models are those models are actually trained on a global context in a lot of different text from lot of different domains, lot of different areas are used to train such kind of models. So in that case, if you just directly fire any query to get the answer from those trained models, it several times it fails to give the appropriate answers for your questions. So this is the scenario. Like suppose you have a very talented teacher in your class, and that teacher knows everything. And when you ask some questions, then you will find that the answer given by your teacher is not appropriate, like not exactly what you wanted. So in that case, there is a smart friend. He helped and he asked the teacher, like, this is the context in which you exactly wanted the answer. So in that case, when the teacher replied the second time, you will find that the teacher's answer matches with your complete requirement. So this is the role of RAG. Now suppose you fire one query to large language model, like how quantum mechanics is different from the classical mechanics, but you want your answer in the context of computer science area, because in computer science also we know that quantum computers are there and traditional classical computers are there. So in that case you want your answers like that, but when you ask this question directly to the large language model, it will give a very generalized answer and it will not contain your context. So in that case, what we do, so suppose you have a very good friend, they collected all the informations that is given in the library related to the means related to your questions or query, like quantum physics, quantum mechanics, classical mechanics, computer science. They collected all the books from your library. They collected all the books from library. Now you want the appropriate contextual documents or files from this data which contains the actual context. So your actual context is quantum mechanics in computer science, classical mechanics in computer science. So you identify that information and then you use your query with this context and then ask the questions with large language model, like your teacher, like we want the answer for these questions, like how quantum mechanics is different from classical mechanics in the context of computer science domain, where quantum mechanics are used in quantum computation and classical mechanics are used in the traditional computation. So how both are different? So in that case, the LLM will give you the appropriate response. So this is the way retrieval augmented generation actually helps in getting the better contextual answers for your questions. So retrieval means you are retrieving the important and useful contextual informations from the resource data resources that you collect that may be relevant for your query, and after that you augment your questions with the retrieved informations and then ask this, combine this, and then ask questions to large language model. Hey, please give the answer for this query according to this context, and then you will get the answer. So this is the technique. Now we will go through simple coding example, like how we can achieve this locally in our system. Locally means I am not going to use any API call or anything. We will do everything locally, means we will use the large language model in our local drive, local system, and we will use our query that will work locally in the system. But before going into the detail, let us go through some basics. First of all, I have used the Olama package. For that, I have used olama.com, and then you will go through the download. You will find that three Olama packages are there. It is at least free of cost till now. So you can I have downloaded the window version. So once you install, it will create a complete directory structure to install the model, different large language models, different kind of text embedding libraries, so libraries related models. So it will install everything in a organized way, and then you can directly call the Olama and related functionalities through Python code. Now other thing is like different large language packages. So once you give the GitHub site of Olama, then you will find that a lot of large language packages or models are available. So in the entire demonstration, I will use the Llama 3 8 billion parameter based model. So now the things are like how you can install and download this model. For this, you have to just take this, copy this part, open your C Windows System 32. So generally you can just translate and go to this folder and then copy paste here and then enter. It will automatically download and install it in the model file that is created by the Olama software. The next part is sentence embedding part, because all the large language models uses some embedding models to embed the text in a vector format. So in the current scenarios, I have used the MXBI embedding large. So main purpose is, it is given here. As of March 2024, this model achieves the SOTA performance for BERT large sized models on the MTEB. So it outperforms the commercial models, like so many commercial models. It's showing the better performance compared to the a lot of commercial models. That's why I prefer to use this. Again, the downloading and this model is easy. You have to just go through, just copy this and just copy paste it here in C Windows system directly. Just paste it here like this and then enter. Then it will automatically download and install in the sentence embedding folder created by the Olama software or Olama package. Now let us start the coding part. So first part is you have to import the Olama once you install, and the next thing is Chrome DB. So Chrome DB is actually vector database system. So what happens when we use the large language models? So all such kind of models are actually transformer based models. So here you can see that all the large language models, mostly they use the decoder part of the transformer. So in this case, they use some embedding mechanism. For example, suppose we say that word 1, word 2, then for each such kind of word, they use some vector format embedding. For example, 003, like that. And for second, again, there will be some embeddings like that. So this format of embedding, so you will not find the text in actual format, you will find everything in the vector format. So to install those things, to query such kind of vectors, we generally need the vector database. Chrome DB is a vector database. We can easily install by using like a pip install Chrome DB. Now, as I discussed, to use the RAG based model, we have to arrange the all the text data, source data. Like I said, like you have a intelligent friend who collected all the text informations from library. So now I have a question like this: what are the key benefits of using quantum mechanics over classical physics? But here we want the everything according to what is written in the quantum mechanics page in Wikipedia. So I want the answer according to that context. So I just use the some starting sentences of that Wikipedia page as a reference text. After that, we call the client of ChromeDB and then create a complete database named docs. Now we will use the sentence embedding package and convert the entire text into the vector format and store in the this vector database. Now the next part is we will use the prompt. So prompt is actually our question. So we will write our question again. We will call the olama.embedding, that embedding model. We will pass that prompt and then we will generate the response, which is actually the embedded vector format output. Now the next part, as I discussed here, is to generate the relevant contextual information. To generate that, we will query to our collection. So our collection contains the complete document set. From that we will query what are the similar things with respect to this prompt. So based on some cosine similarity scores, it will return all those contextually similar things here in the form of result. So we will store this result in a form of a data. Now our final part is to query the Llama 3 model. Like I say that we will query this, but we will pass this question in the embedding format and we will pass this contextual information in the embedding format, like we want the answer for this query with respect to this context. So like here we will call the Llama 3 model olama.generate Llama 3 model that I downloaded and used here, and then our output will contain the answer for this prompt and for this data, and then we will print the our response. So when you run this, you will find a very good and sophisticated answer for these questions. The summary of this answer is like: quantum mechanics offer a accurate, comprehensive and nuanced understanding of behavior of particles at the atomic and subatomic level. Means it contains a very good and systematic answers that you will not get when you just directly pass this question to that Llama 3 model. But when you give the context as given in the quantum mechanics, then you will get the answer which are according to that context. So it actually satisfies the context. It is not a generalized answer. So this is the way, this is the reason people are these days are using the RAG based methods with all large language models. Now the next thing is we can use RAG based techniques not just to answer the questions, not just to get the answer of the questions. We can also do a lot of useful things. We can use this RAG based method to generate the contextual knowledge graph from the large language model package. We can convert the entire text into flow diagram, and we can do a lot of meaningful things by using the large language models, by using the with the help of RAG models. So in the next tutorials I will explain all those things in details, and hope I think you would have liked this tutorial for its simplicity. So thanks for watching.